You saw the title. Yes, we've got new November 2nd images of 3I/Atlas. But here's the kicker, this thing is huge, fast, and threading the inner solar system with timing that looks planned.
Professor, the last time we spoke, which was like the day before yesterday, you were saying that when it went behind the sun, the natural explanation for the non-gravitational acceleration in the thrust might be because it burned off a bunch of chemicals or something, and that was giving it the thrust.
We see other comets in the solar system that have a beautiful tail away from the sun. Behind them, Lemon is an excellent example. But in our case of 3I Atlas, it looks like a fuzzy ball of light.
What is going on?
Yeah, that's very surprising because there should have been a very massive cloud of gas and dust around it, based on what we know about comets. In fact,
why does a body reportedly 1,000,000 times more massive than Oumuamua move even faster, and hit a Mars, Venus, Jupiter sequence while perihelion hides in solar conjunction? Stay with me. We'll unpack the mass-velocity paradox, show the fresh telescope shots, and map the stealth approach. Like reading a tricky tide line, the pattern makes more sense when you see the current, and what it's pulling toward next. Before we move on, I'd like to ask you a small favor. If you appreciate this content, please take a second to like this video and subscribe to the channel. Over 98% of you watch the videos without subscribing. It costs you nothing, but it makes a huge difference to us. So, did you click the subscribe button? Great, thank you so much. Now, back to the video.
Even after it passed through perihelion, it was heated by 770 watts per square meter, and we know that the previous plume of gas was mostly carbon dioxide by the solar radiation and the solar wind, but we don't see that. So the question is, what's going on? One possibility is that what evaporates from it are fragments of ice, and they get vaporized by sunlight, and carbon dioxide ices can sublimate at a much lower temperature than water ice. So we should have seen it break up, or at the very least disintegrate to a very dense and massive cloud of gas and dust that is pushed away from the sun.
The new November 2nd shots look smooth, almost boring. The captions don't. They run upstream, mass on the heavy end, speed on the high end, like a rip cutting across a lazy tide line. Here's the rub you feel in your gut. Reports talk about iron scale heft, while the velocity reads higher than what we saw from earlier passersby. Those two traits shouldn't sit in the same boat. Big mass means more inertia and cleaner, gravity-led arcs. Yet Atlas is chalked as the faster one, not the sluggish hauler. That upends the rule of thumb. We expect a bulkier body to soak up nudges and stick to the textbook path. Instead, we've got a claim that beats the pace set by the first famous visitor. Like a heavy trawler lifting onto plane and sprinting past a skiff in flat water, the pairing jars your sense of motion. For context, the short roster of interstellar visitors links smaller size with quick exits and mild nudges from sunlight or outgassing. The other end of the scale looked larger, slower, and more comet-like. Atlas is placed beyond that band, high speed, hefty mass, so the dot sits off the old chart. Now layer in the track. Retrograde motion means it's running against the flow of the planets. Most arrivals slant in from odd angles, cross the ecliptic, and peel away like crosswells. This one sits close to the ecliptic, the main shipping lane.
Before they have a chance to turn around and show up as a plume of glow behind it, away from the sun. That's one possible interpretation, but otherwise I just don't know what to make of it. So what I'm saying is, you know, there are things we don't fully understand about this object. That's what makes it exciting, and I think all of us will wait for the data that will come in the coming weeks. There was also a blue color that was noticed just a few days ago, and also, in addition to that, it became brighter by a factor of 5.
That pairing, retrograde and near flat to the plane, stands out. Why does that matter? Space offers near all angles. Locking within a narrow strip while moving counter to the pack is rare by geometry alone. You don't get that alignment often without a strong setup. It tightens where and when close passes can happen. Because of that, the line points straight through prime lanes. The timing steers toward perihelion when glare blots out detail. So the bottom line lands simple. The mass and the speed don't act like loose drift, and the path runs too clean to shrug. Next up, we map that stealth thread and show why the schedule looks set, not lucky. What are the odds an incoming object turns past Mars, schemes Venus, nods to Jupiter, and hits perihelion while we're blinded by the sun? Let's lay it out clean. The claim is a tight Mars, Venus, Jupiter sequence, then closest approach lands during solar conjunction. From the ground, that glare knocks out our view right when heating and activity peak. So the key swing happens off camera. That reads less like drift and more like waypoints. Each pass sits in a narrow time box. Miss by days, and the angle shifts, the path widens, and we'd get longer looks. Instead, the windows shrink. Our chance to study shape, shed, and spin gets cut to slivers. Think of running a channel at slack tide so the current won't show your wake. Perihelion in conjunction does the same. The show is there, but the glare flattens it. By the time the light eases, the wake has spread and the clues are thin. Here's why that matters. Conjunction drops ground-based visibility to near zero near the sun. Short arcs, low contrast, and safety limits shutter many scopes. To hit that slot and stack those planet passes, the phasing needs to be very tight across a long path. Small errors grow fast at interstellar speeds. We also need the missing frames. Reports note a narrow image window and partial access since then. When key images sit locked, we can't test shape, albedo, or find jets. It raises the stakes for outside checks. Now the material flags. Negative polarization, low water, and a high nickel-to-iron reading, if verified, push this object out of the usual bins. Negative polarization that steep hints at unusual surface texture. Low water fights the dirty snowball model. A nickel load far above iron leans toward processed metal rather than natural ore. So watch the late November through January runs. Teams will chase debris, faint jets, and color shifts. That's the test water. The takeaways land firm, odd timing, metallurgy-like signals, and a stealthy arc call for open, high-res data now. Next up, decide how to fish it, treat Atlas like routine bycatch, or gear up for a once-in-a-career catch and log every pull. Speed, mass, and timing line up like a tight drift. You don't see that often by chance. Retrograde on the ecliptic, a clean pass sequence, and perihelion in glare point to a rare setup. The trick is to watch for this sign, patterns that hold across steps, not just one snapshot. So here's the ask. Release the high-res frames now. Open access lets everyone check jets, debris, and color changes during the late November to January runs. Track it with us, we'll post targets and watch windows. Next update, we test the stealth route against fresh spectra and debris checks. Watch how the current turns.